Good afternoon, students. So today we are going to discuss the introduction part of nuclear power plant. Yesterday we were discussed the introduction part of nuclear power plant. In that we are discuss about what is mean by nuclear power plant, what are the important components in the nuclear power plant, how it is working, the principle of operation, everything we were discussed, and some more about nuclear power plant, that is different parts of a nuclear reactor. That is, we are discussed about nuclear core, control rod, moderator, all those things we were discussed yesterday. So today we are going to discuss little more about on nuclear power plant. Okay, then we can go with the one short video related to nuclear power plant. So first we'll see the agenda of today's session. So today we are going to discuss about the important components in the nuclear power plant and principle of operation. So yesterday we discussed about the chain reaction and overview of nuclear power plant. So today we are going to discuss about little more on nuclear power plant. So the main drawback of nuclear power plant is disposal of waste. I already told, okay, uh, the main problem in the nuclear power plant is, okay, the uranium U-235 fuel. So how we can generate the heat with the help of fission process, we develop the heat energy. So you know very well the about the chain reaction. Last class we discussed. So one free neutron is impact with the nucleus of uranium U-35. So a bombarding action will take place due to that chain reaction that will be happen. So due to the impact. So what will happen? A high amount of heat energy is liberated. So with help of that heat energy, we can develop steam. Okay, that steam can be used in the turbine to generate the power. So this is actual happen. So what I'm trying to say is, if we use this uranium U-35 mean, okay, due to the reaction, okay, the heat energy is developed. So after some time, okay, after some usage of same reaction, the uranium fuel is again it should be disposed because it's a radioactive material. I already told. So if you're not properly disposed, mean that will affect the human and also handling person and environment. So what I'm trying to say is, so we have to take care of the disposal of uranium U-35 material. So for that, you have to use a proper disposal method. So how we can dispose means, so normally uranium U-35 material is disposed with help of decking method. By decking means, okay, in a high amount of material is filled with a box, okay, a container box. The container should be uh, it should be protect the radioactive waste, and also it should be kept in a wooden block. That wooden block is kept in the uh, soil of the seashore area. Likewise, the seed, that is uranium seed, what do you call it? In the name of tablet. Normally, uranium is in the form of tablet. So after usage, that it has okay, it has some the uranium wastage seed is kept it in the container, and that should be properly packed with a wooden box. After that, it will kept on the sea source area, okay, with the digging method. So by this way, we can dispose the nuclear waste. So what I'm trying to say is, so if you not properly dispose it, so it will affect the human. So that's why, okay, the disposal method is playing a very important role. So uranium 235, okay, is handling is one very major impact in the nuclear power plant. That's why we have to take care. So during the action, that is during the chemical reaction, a high amount of energy is released. That is also we discussed yesterday. So with help of that heat, okay, the energy of heat, okay, we can utilize to develop the power. How much power we can develop means that is 200 milli electron volt power we can produce at the rate of we can say that will be equal to 10 to the power of 6 electric volt. Okay, that will go. So 1 milli electric volt is nothing but 10 to the power of 6 EV, that is electric volt. Okay, so by this way we can develop the power in the bombarding action. So high amount of energy is liberated during this process. So this process is continuously this happens. So that's why we are call it as chain reaction. So if you want to stop this reaction, you have to use a nuclear. No, sorry. If you want to control the reaction, means we have to provide a moderator. That moderator purpose I already told. It is used for slow down the neutron. Okay. And similarly, if you want to cut down the reaction, means you have to use control rods. So with help of that only we can control this chain reaction. So what I'm trying to say is, if you are not controlled on proper manner, definitely radioactive material, okay, radiation come out from the nuclear core. So you have to take care of the radiative waste, so that we have to build the core in a concrete shell. Okay, so normally a nuclear core is kept in a concrete shell, so it should have high uh, porosity, and not porosity, less porosity and more strength. Then only the heat radiation should be avoided. So what I'm trying to say, so the proper concrete wall should be located around the core, then only we can minimize the radiation. Even though some minute radiation is kept away from the concrete, again for that we have to provide some thermal shield. Okay, so with help of the thermal shield we can able to control the heat as well as radiation. So this method, by adopting this method, we can thermal shielding method. Okay, we can control the radiation as well as heat. So this is the method to control the radiation. So that is one main disadvantage in the nuclear power plant. And most of the countries now they are focusing nuclear power plant because high rate of production. So I already told, if you use 1 kg of fuel, that will be equal to 4,500 ton of coal energy. How if it is used in a coal thermal power plant, that energy how we produce, so that will be equal to 1 kg of uranium energy. So that's why all the countries are focusing that nuclear power plant. So that was the main intention. All the countries focusing to a nuclear power plant. If you see in the last 5 years before, there is one earthquake has happened in Japan. That is Fukushima power plant. So due to the earthquake, okay, the structure of the concrete wall is damaged. So the radiation is come out from this Fukushima power plant. So people are feel okay. It's so sad because radiation may be come out from this power plant. So that's why the people are feel okay. It's not a good thing for the society, but at the same time, the country also focusing the production of electricity, because the GDP of the country is depends upon the production. So the production is happened because if we use electric power proper manner, then only the production will be happened. Our manufacturing sector will grow up. So for that purpose, power is very important. So if you want to meet out this demand, nuclear power is very essential. If you compare with the grown countries, okay, they are turn it into the renewable energy sources. All the grown countries are now they are focused to the like solar and some additional renewable energy sources like wind and tidal power, geothermal. So that kind of renewable sources they are using to produce the electricity. But most of the fast-growing countries they are focusing only nuclear power plant, because the amount of production in the power in the nuclear power plant is more. So our demand is more, so we have to focus nuclear power plant. But in future, we have to go with some other alternate solution, because due to this, a lot of pollution. So that means a lot of problem is maybe arising to the surrounded people due to some radiation. So that's why, okay, people are again agitating this nuclear power plant. So we have to take care first two things. One is radiation and also heat. So and everything. So that's why, okay, people are more conscious about the uh, their health, okay, related to this power plant. So people's and also the government also they are focusing on the radiation, okay, threatening factor. So here our nuclear reactor is shown in this figure. This is a nuclear reactor. So here you can see the thermal structure. The thermal structure is formed with help of a concrete material. So here, so the core is the center part. In that core, we have provided the uranium material in the form of tablet that will be stored in your core. Okay, around the core we have a thermal sheet. That thermal sheet is nothing but a concrete structure. Okay, and inside your thermal sheet there will be a steel structure is also there. So with the help of this two layer, okay, steel structure as well as concrete structure, we can avoid the radiation. Okay, so we can mostly avoid it. Only minute, very minute radiation is there, but that is also nowadays is completely arrested with the help of concrete and steel structure. Only the disposal is we have to take care. So this is the present scenario. Okay. So here you can see the graphite moderator and boron control rod. So the moderator is used to slow down the neutron. I already told this is the moderator. You can see in this picture. And control rods is placed inside the core. So when the neutron is that is bombarding action takes place, that means impact with your nucleus of uranium-235 material. So the chain reaction is started. So if you want to control or cut down the reaction, or if you want to shut down the plant, please, we have to insert the control rod. So what will happen? So while inserting the control rod, so the movement of nucleus is stopped. So due to that, what will happen? The continuous reaction is stopped. That means chain reaction is stopped. So automatically you can cut down the power production. So likewise, the control rods play a very important role for shut down the plant. Normally, control rod is made up of boron or cadmium material, and moderator is made up of graphite material. In addition to that, we have used water. Okay, so here I used water or D2O, that is heavy water. So due to high temperature, it should withstand. That is a turbine that expansion process takes place in the turbine. So automatically generator is rotated, so power will be produced. So by this way, we can develop the power with help of nuclear power plant. So this is the general principle about nuclear power plant and disposal method and construction. So radiation shield should also acting as a thermal shield. So people working in the surrounded area, that is working people in the power plant and surrounded area should be protected with help of this thermal shield. So thermal shield is you have to keep in mind. Whereas two things, one is steel construction. It's that is the steel construction is inside the your nuclear core. Then after that, we have to provide the concrete structure. So with help of that, we can control the radiation as well as thermal conductivity. That means heat generation we can protect. So heat is made may not be dissipated from core to outside. So this is the method we are adopting in the nuclear power plant. So now we will see one video related to nuclear power plant. In the next class, I will show to you how the fuel, that is uranium U-35, is stored in a tablet form. I already told in the last class also. So today you see the working principle of nuclear power plant video. Then next class I will show how the nuclear fuel, that is nuclear power plant fuel, uranium U-35 isotope, is stored in the core in a tablet form. That will show to you. It will be understand. That video will teach you how the pellets. So normally the uranium U-35 is form of tablet, no, that is called a pellet. So how the pellets are placed inside the core, that will be you can see, then you can understand better. So now you can see the video, you will understand the working principle of nuclear power plant. So please be right.
nuclear power plant. neutrons are on.
So by this So due to nuclear fission process, so one neutron is combined with uranium-235, then it is split into two parts. Again, that free neutron, if it if impact on the uranium-235, so again it is chain reaction is takes place. So this is called fission process or chain reaction. So that fission process takes place in your nuclear reactor. So 1 kg of uranium produced as much heat as produced by 4,500 ton of high grade coal. I already told. Then you can see the nuclear power plant. So the nuclear chain reaction takes place in your nuclear reactor. That heat energy goes to your heat exchanger area. So in that heat exchanger, water goes to the tubes, okay, and heat is surrounded the water tubes. So automatically water gets heated up and converted into steam, okay. So that steam goes to turbine, and the expansion process takes place in the turbine. So turbine is rotated, so generator also rotated, so you can get the power. So the remaining gas is low pressure, low temperature gas that goes to the condenser. So condenser is a device which is used to convert the low pressure steam into low pressure water. So that is the purpose of condenser. So here you can see how the steam is, okay, goes to the turbine and touch with the turbine blades. So automatically the turbine start rotating. So we can get power. So after that, the condenser, okay, is cooled. The steam, low pressure steam is cooled with the help of condenser. Okay, so for that you have to use cooling tower. So with the help of the cooling tower, the cool water is circulated around the condenser. So low pressure steam is converted into low pressure water vapor that will goes to boiler feed pump, and again the water goes to the heat exchanger. Okay, so here you can see the nuclear reactor. So it has moderator and also control rod. So your uranium U-35 material is formed as a tablet. So if you want to control or shut down the plant, means you can insert the controller. So here you can see how the control rods are inserted. By this way, you can stop the reaction, that's chain reaction. So the power production is stopped or chain reaction is stopped. So if we introduce a moderator, means that used to slow down the reaction, chain reaction. And finally, the cooled water is circulated, is also in the heat exchanger. So with help of the cool water, the water is converted into steam. So that's why we are used boiler feed pump. Okay, and coolant also used. I already told D2O, that is heavy water is used to cool the reactor because high amount of heat energy is liberated in the nuclear reactor. So we want to control the heat. That's why D2O, a coolant is used to cool the reactor. So this is about the working principle of nuclear power plant. So next class we are going to see the different type of nuclear power plant and how the nuclear fuel, that is uranium-235 material, is stored in the nuclear reactor. That we will see in the next class. Okay. So up to this we covered the concept, that is working principle of nuclear power plant. So you have any doubt, now you can ask.
No, sir.
Okay, thank you. Now you can leave. Okay, Madan Prasad and Udit Vishnu or Venkatramanan, kindly send me today.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
So now you can leave. Thank you so much. Next class we will see. Okay, so 12th onwards you have an examinations. So it is a descriptive type. So we have already covered 1.5 units. So already we are running in third unit. So we already covered. So kindly prepare. So I put all the PPTs in the Google Classroom. I put the questions and small 2 mark questions and also big questions in the Google Classroom. So please make use of it. Okay, and prepare for the examination. Okay. If you have any doubt, you can contact me through SMS or by call. Okay. Thank you so much. Now you can leave. Thank you.